Okay, here we go. We got a new video, and this video we're going to be going over section 8.2, and this is where we calculate the probability from a sample proportion. So it's pretty interesting. There's a lot of things that aren't explained in this section, and when you're trying to understand it and process it, there's a lot of information that needs to be filled in to help you better understand what a sampling distribution is. Okay, and so that's what we're going to go over in this video, this homework problem, section 8.2, problem number 4. The first part, it says describe the sampling distribution of p hat, and then assume that the size of the population is 15,000. The sample size of the proportion is 500, and the population proportion is 0.5. All right, let's talk about that for a second. So they told us that we have a sampling distribution, and that's p hat. So let's make note of that. Put in my point here. P hat is a sampling distribution. Now, let's say we have a huge population of 15,000. And let's say out of the 15,000, the population proportion is exactly 50%. Okay, so we have this gigantic proportion. It's the population proportion. Let's go back one. It's pretty big, 15,000. Okay, and then we have some proportion out of the 15,000, 50% of them is one thing, the other 50% is not that thing. All right, and so now what we want to do is answer some questions about the sampling distribution p hat. And the thing about that sampling distribution is it's not the entire population. It's only 500. So the sample is 500. Now, if we take one sample of 500, and I'll call it p hat 1, we might get 48%. If we take another sample of 500, all samples 500, all of them, the same size, this one might be about 51%. I continue this process. Let's see, hold on. All right. I consider the process, just keep doing it over and over again. There's going to be quite a lot of different sample proportions of 500. But what we want to do is describe the distribution of them. So let's do that. We go over and over and over and over, all the way down. That's this. Let's see. The actual sampling distribution. And if we were to graph them all out, it'd be this. We would get a little bit less than 50%. We'd get a little bit more than 50%, but all of these combined, averaged out, will also be 50%. So the first thing you need to know is that the population proportion is equal to the sampling distribution proportion for some n big enough. Okay, there's conditions. First of all, the n, the sample that we're getting out of that 500, it has to be a simple random sample in order for that to happen. Not much bias at all. None. If there is bias, then there's bias. But it has to be a simple random sample pulled from the population. Also, the distributions, as we check them, they must be a normal distribution. So as we do another sample of 500 and another sample of 500, we're only doing samples of 500. There are an enormous amount of samples of 500. I couldn't say an infinite amount, but it's pretty close to it, right? There's a lot of samples of 500. And when we average them all out, the average will actually be the average of the true population. And so that's why we can say that those two are true. The other thing is that the sample size times, let's say 500 times p times 1 minus p must be greater than 10. Okay, so 50% of 500 is already, I mean, that's 250. And then another 50%, because 1 minus p is another 50%. So that's going to chop it down. Half of this, 125. And you know what? That is much bigger than 10. So the two conditions are satisfied. The sampling distributions are normal when they're plotted out. And also the sample size times the population proportion times the complement of the population proportion is bigger than 10. And so once those are true, we could say two things. P hat is equal to P, which we've already said. This thing is, this is, okay. Well, let's see. Also, the standard deviation for the sampling proportion, so this guy, for this will be the square root of p times 1 minus p divided by the sample size n. That's our sigma. And so you have to calculate that. So that's 50% times another 50% divided by 500. And then we're going to take the square root of this. So that's 0.5, 0.5 is 0.25. Now this is a fourth, and if we multiply a fourth by 5, we're actually getting 1 over, or a fourth by 4, we get 1 over 20,000. Now, 20,000 is not a perfect square, all right? So we're stuck here, but we can approximate this number. We can plug this into the calculator, and we get that. And that's probably going to be the first step. That's probably going to be one of the first steps that we do. So let's go through this. N must be less than or equal to 5% of the population, and also N times P minus P must be greater than or equal to 10. So I like this one, but it has to be approximately normal. Okay, so approximately normal, the sample size has to be 5% of the population, and N times P times 1 minus P must be greater than 10. Let's check. Good. Determine the mean of the sampling distribution. It should be 0.5. Let's check. Now, how did I get 0.5? It's what the population was, 0.5. And we knew that because it satisfied the conditions. Now this guy, calculate little sigma of P. Well, here we're going to have to plug all that into the formula, and we figured out that that was the square root of 1 over 2,000, rounded to 3 places. So let's see if we can do that. Round it to 3 places, that's 0.022. Let's see this. Yes, okay. And oh, that was the end of the question. I thought they were going to ask a question about the probability. It seems like they didn't do it there. Huh. All right, let's just try this one. So this would be we'll do the square root of 0.736 times 0.264, and then we're dividing by the, whoa, yeah. We're going to divide all that by 1,400. .012 when we round. Okay, so those work for that one, but we need to find one that has 5 parts to it. So here, describe the sampling distribution of p hat. Well, it needs to be approximately normal. The sizes of all those other ones must be 5% less than the population, the entire population. Also, the sample size times the proportion times 1 minus the proportion must be greater than or equal to 10. So I'm going to go with B. Now, if that is true, then p hat will equal P, which is 0.8. And then what would that be? Well, E8 is 0.8. 0.8 times 0.2. Let's see. That's 0.16. So the square root of 0.16 divided by 10,000? Would that just be 40? .8 times 0.2? Huh. 0.004? Okay. Wait a minute. 0.8 times, oh, divided by 125. Okay. So we have to do the square root of 0.16 divided by 125. It has to be n, not big N. That's 0.036. 0.036. Oh, they said 6 places as well. All right, we got 6 places. Six places. Oh, okay. Now, and here's one where they want you to calculate the probability of obtaining x equals 105 or more individuals with the characteristic. And that is, what is p of hat greater than or equal to 0.84? So graphically, what this will look like, it's a good question. Hold on. It would look like this. We would have, let's see here. Oh man. Let's see. All right. 0.84 would be in the middle. So we got 0.03577. That's going to be the sigma. So all we got to do is figure out what the probability of this is going to be. But we know 8 is in the middle. So let's use StatCrunch. And for this, we go into the calculator and we go into normal. And the mean is 0.8. The standard deviation is that 6-digit number. I'm going to copy and paste that. Oh, they won't let me. So 35778. 35778. Let's see if we can remember that. And we need to switch the sign around because it's everything greater than, that was a point 84. One, 3, 1, 8. 4 places. Whoa. Let's see. Okay. So we're getting 0.1318. We need to check that. Okay, that worked. And and there's another one. What is the probability of obtaining 90 or fewer? Okay, and that's the proportion 0.72. And how do they get that? 90 over 125. Let's check that. 0.72, everything less. So we can go back to StatCrunch. Those two are the same, but we're going to switch this, and we're going to put it to 72. Everything 72 and lower, that's going to be 0.0127. 0.0127. Okay, we got through that one. That was a good one. All right, so we're going to end the video here. Hopefully that was helpful. Let me know if you have any questions about anything there.